Good morning, everybody. You're watching my YouTube channel for Chief Mate Phase 2 candidates for the subject Engineering Knowledge. And today we shall be take up one of the topics under the numerical chapter, that is power calculation in the diesel engine. Power. So before going into the basically the power that is just revise some basic formula which we have done in class 8, 9, 10, which is force is equal to pressure into area, and work done is equal to force into the distance that a body moves expressed in joules, and power generated is work done per second, which is expressed in joules per second, and the common unit is watts. So this is about the basic formula using which we shall proceed forward to calculating the indicated power that is generated in the engine. This is a piston that you see. A pressure is acting on top of the piston. That pressure is due to the fuel combusting, and that fuel combusting pressure acts on the piston, pushing the piston down. The pressure is acting over the piston, which is of an area A, let us say, and the piston travels a distance capital L. So we can say that work done is equal to the force into distance moved. The force is the pressure that is acting on the piston multiplied by the area over which it is acting. So pressure into area, and distance is the distance that the piston has moved from top to bottom, that is capital L. And so power we can say as pressure P into area into the length or the distance that the piston travels into revolutions per second, which would give us in watts. And if it is for 4-stroke engine, then the number of revolutions per second has to be divided by 2, because in a 4-stroke engine every alternate revolution is a power revolution. So to calculate the pressure, we have to calculate the area of this, or rather measure the area of this. Instrument called a planimeter is used, by which we get the area of this diagram, and we divide it by the length of this diagram, and multiplying it by the spring scale, we get the mean pressure. So the average mean pressure over here we see is A millimeter square, the diagram, divided by L millimeter, into K is the spring scale bar per millimeter, which has to be converted into Newton per meter square. So it is multiplied by a factor 10 to the power of 5. And now that we have got the mean indicative pressure, or the mean pressure that's in the cylinder, we insert this mean indicated pressure in the formula for power, that is mean indicated pressure, which we have just calculated, into area of the piston. We will calculate from the diameter of the piston, length of stroke, that is the distance that the piston travels from top to bottom, and number of power strokes per second. And the final formula comes as this: if it is a 4-stroke engine, you have to divide it by 2. So this is how the indicated power for 1 unit is calculated. And if there are 6 units in the cylinder, you shall have to multiply this value by 6. If there are 8 units in the cylinder engine, you have to multiply it by 8. So this is how we calculate the indicated power of the main engine. Now we shall go to a new topic called machine, which has got an input and losses and output. So we can say input minus losses is equal to output, and efficiency of a machine is equal to output divided by input percentage will be multiplied by 100. So main engine is a machine Input to this is indicated power. It will have its own losses. Output will be brake power, or it is also called shaft power, because the next machine being a shaft, so the mechanical efficiency of the engine can be expressed as output by input, brake power by indicated power. The next machine in line is the shaft, input to which is the same brake power or shaft power. It has got its transmission losses. Output from the shaft is called DP or delivered power. So we can say that the transmission or shaft efficiency is delivered power by brake power. Delivered power is the output, brake power is the input, and we know efficiency of any machine is output divided by input. And the third machine that comes is the propeller. Input to this propeller is delivered power. Propeller has got its own losses. Output from the propeller is the thrust power. So the expression for propeller efficiency would be output by input. Output to the propeller is thrust power. Input to the propeller is delivered power. So this is about these three machines: the engine, the shaft, and the propeller. Next we'll go to the last machine, that's the ship hull itself. Input to this is the thrust power, there is hull losses, and output is the effective power. This is the effective power, this is the power which actually makes the ship move along the water at that speed of V, whatever it is, that GPS speed or speed over ground. And the hull efficiency can be expressed as again output, that is effective power, divided by input, that is thrust power. So gentlemen, that's all for this episode. In the next episode we shall see if we could solve some numericals and give you an idea of how to solve these numericals.